So that's really interesting. I mean, everyone's heard of Watson, IBM's Watson, and everybody knows that Watson won Jeopardy. I think a lot of people realize IBM is now trying to move Watson into healthcare. The results you just described are really amazing. Do you think that we're heading into an era down the road where tools like Watson are going to replace doctors?
So first, before I answer that question, first I want to give a little background about how Watson competed in Jeopardy. I mean, besides the advanced analytics techniques they have used, the amazing natural language processing pipeline they have developed, another secret I think is very important for the success of Watson winning Jeopardy is the rich training data source that are available that related to Jeopardy challenge. In fact, there is a website called jarchive.com that record all the historical competition in the past in Jeopardy since 1983. And a lot of those questions are general knowledge that there are associated Wikipedia articles that provide very rich meta information about those questions. So those two important data sources helped the Watson team to develop their algorithms, to train their algorithm on those historical questions. So that lead to a very amazing result. But in medicines, neither of those sources are available. There's no good question database or question answer database that are available. There's no good meta information related to all those clinical concepts. So it's a lot more complicated even to get to that stage. So what they have done, I mean, before I left, is to look at the US medical licensing exam questions and trying to at least tackle that first, because those are the available question and answers. But just the space of the medical domain is so large, and the question and answers are a lot of times there's no clear yes and no answers, so it's a lot harder. But there are many clinical institutions are very interested in using Watson. So there's very big medical research center like MD Anderson, Sloan Kettering Memorial Cancer Centers. They all partners with Watson to use Watson for their diagnosis. So that's definitely a promising direction. I hope they succeed.
It's fascinating to speculate about what something like Watson might be able to do if you could train it on that vast amount of data. So as you look ahead for the next few years, 5 years or so, where do you think we're going to be in terms of big data and analytics in healthcare?
Yes, so it's definitely a very hot area, big data analytics in healthcare. And so there's a paradigm shift from the traditional, more small-scale statistical approach to a more system approach. When I say system, I mean computing system. So they're not a single algorithm that's going to work. It's a pipeline of sophisticated computational tasks that put together and run in a very scalable platform, like high-performance computing centers, or in a cloud environment like Amazon Web Services. So in particular, I think there's a great need for making the data more usable using analytics techniques. So there's a new push called phenotyping. That's really means how do you convert those messy electronic health records into meaningful clinical concepts using algorithms. Rather than require the data to be good to begin with, why don't we develop algorithms that can automatically clean the data and turn them into more usable, high quality data that can support research and discovery. So that's the phenotyping effort that a lot of people are working on. That's about the input to the analytics platform. Then there's the middle part where people trying to build those analytics, predictive analytics, that used to take months, right? For every disease target, every data set, you have to spend months just to get the right data, build the model, then validate that. But now, everybody want to use predictive analytics, and there's thousands of diseases and conditions people want to build a model for. So how can you scale up to build those models quickly? You need a very scalable and large-scale platform to support that. So a lot of people leveraging parallel computing and like MapReduce to do that kind of work. That's the processing part. And also, finally, the output, right? So we so far only talk about accuracy and how good the models are, but in order to make use of those models in clinical decision support, you really have to make the model intuitive so that the decision maker, like clinician, doctor, can understand, can explain the result to the patients so that they believe and follow through the recommendation. And their work on leveraging similar patients' history and recommend what happened to those, worked for those similar patients to the current patient as an intuitive method to explain the recommendation. So that's the final output part, right? So all the entire system, input, processing, and output need new computational method. And I think that's a very promising future for healthcare analytics.
Well, thank you very much. I think you've really helped the students understand not only where we are, but to see that there are many, many years of interesting research and development ahead of us. So maybe some of the students will decide to join that, which would be a great result. So thank you very much.
Thank you.